Hello and welcome to my video. This is Hamza here with you, and I'm a cloud professional with expertise into Docker containerization and Kubernetes. In this video, we will be demonstrating how to install an OpenShift 4.10.3 cluster on Google Cloud Platform using the user provision infrastructure method. So this is going to be our deployment flow. On our Google Cloud Platform, we will first be creating an OCP network. And within that OCP network, we will be creating two subnets. One would be the master subnet and the other one would be a worker subnet. The master subnet would be hosting all our control plane components, while the worker subnet would be hosting our worker plane components. From an instance perspective, the first instance that would be created would be the Bastion host. And once we have this node ready, we will be logging into this node. We will be downloading all the necessary binaries such as the OC, the kubectl, the OpenShift install binaries, as well as the RedHat core operating system. And we will go ahead with creating our Bootstrap node first. Once this Bootstrap node is created and it is ready, we will go ahead with the creation of our master nodes within the master subnet. And once our master subnets are bootstrapped completely, we will go ahead with the creation of the workers of our worker nodes. But before we go ahead with this entire flow of our actual OpenShift cluster, we will also be deploying a lot of Google Cloud related infra components. This includes creation of the IAM project, the service account, the actual network, sub-networks, its cloud router, the entire cloud NAT system. We'll be creating two cloud NATs for each of our subnets. We will be creating a private DNS zone as well as a couple of load balancers. And once our installation is done, this is what our final architecture would hopefully look like. We will not be having our Bootstrap node anymore part of the cluster. We will just be having our 5-node OCP cluster, as we can see here on the screen, and all the communication between these cluster nodes would take place between via these two load balancers. The one over here in the master subnet would be needed for any kind of API related communication, and this load balancer that is present within the worker subnet would be required for the application related traffic to be communicated within the cluster. We will also be creating and configuring a reverse proxy on the Bastion host so that we can have access of the OCP UI externally on our local machine. Other than that, as we discussed earlier, we will also be having a private DNS zone that would be part of the OCP network, and we will also be having two clouds for we'll be having two cloud NATs for our subnet instances to reach out to the internet and download the necessary packages to install and spin up the OpenShift cluster. So let's get started and let's get into the practical to deploy our OpenShift cluster. So I have created a GitHub page that includes all the steps in detail about installing your OpenShift cluster on Google Cloud Platform. It has been documented in very detail and with explanations too. And I will be sharing the link to this video in the video description. So let's get started. I'll just move this window to a different screen so that you can see my Google Cloud Platform console. As per the documentation that I've created, the first step that we need to do is to create a project within your Google Cloud Platform. So for that, we need to, in my case, I've already created the project, but I'll just simply show you how to do it. Let's go to IAM admin and click on create project. Here you can simply name the project. In my case, I've given it the name of OCP project, and you can simply click on create. Once done, the next step for us is to create our service accounts. So it is once again under IAM and admin. We click on service accounts, and I will be creating a new service account for this implementation. So let me call it OCP SA2. Create and continue. For the role, I'm going to give it the owner permission because I'm the one who's going to be using this service account. You can refer to the guidelines and assign the necessary roles as that just grants the limited access for the necessary actions required to create a cluster. Okay, so now that we have our service account created, I will create a new key for the service account. This will be required for spinning up our Google Cloud objects from the CLI. So let's create a JSON key over here. So this has been created. The next step for us is to create a network. In my case, I have already created the network from before because my Bastion host is already running, but I'll just show you how this needs to be created. Let's go to VPC networks. Create a VPC network. Give it any name. In my case, it is OCP network, for example. For the subnets, let's keep it custom because we need two different subnets. For the first one, you can name it something like master subnet. For the region, ensure you give it the one where you want to spin up your cluster. Give it a range. For the private Google access, ensure you keep it on, and for the logs, you can keep it off. It is showing red because I already have the subnet created, but in your case, it shouldn't show any kind of warning. Again, in a similar way, you have to create it. I'll give it a different subnet range. Private Google access on, flow logs should be off. For the firewall rules, I would really recommend you to check all the checkboxes that would be auto-populated here. This is mainly to allow all the communication between our cluster nodes. This does not mean that that there will be external ingress traffic coming into the cluster. No, this is going to be a private cluster. We will only be able to access our cluster using our Bastion host. For the dynamic routing, let's keep the remaining stuff to the defaults, and you can click on create. Once you have created your network, we need to create a firewall rule. This is basically to allow all access to the Bastion host. You can name it something like allow all to Bastion. The logs can be kept off. The network needs to be the one that we just selected. I have given it a priority of 100. You can keep it whatever that you want. The direction would be ingress. Action and match would be allow. For the targets over here, you just need to specify the network tag name that you would be assigning to your Bastion host when you are creating your Bastion host. In my case, I have assigned my Bastion host with the network tag name of Bastion, so that's why I'm giving it over here, so that this firewall rule can only apply to that Bastion host. For the source ranges, I'm going to give it an all. Wildcard entry for all the IP addresses, and for the protocols and ports, allow all. I'm not going to create it right now because I already have this rule in place, but in your case, this should be fine to get you access to your Bastion host completely. Okay, so at this time we've created our network, we've created our firewall as well. The next step for us is to create a router. So for that, we need to go to hybrid connectivity, go to cloud routers, create a router. I'm going to name it as OCP router. For the network of OCP network, it needs to be in the same region as my cluster. It's Asia Northeast 1. Let's keep the remaining stuff to the default. So now that we have our router created, the next step for us is to create NAT gateways, which are basically the cloud NATs. So let's create two NAT gateways. One would be for our master subnet and the other one would be for our worker subnet. You can give any name that you want. I'm giving it OCP NAT master gateway. For the network of OCP network, the region would be the same one. The router is the one that we just created. For the NAT mapping, I will select custom, and for the subnet, since this is the master gateway, I'm going to select the master subnet and create. We'll repeat the same steps for the other gateway for our worker subnet as well. Let's give it a name. I'm going to create the OCP network or gateway. OCP network. Same router as before. Again, this needs to be custom, and this time I'm going to select the worker subnet. Just keep the remaining stuff as default and click on create. So now that we have our two cloud NAT components and the cloud router ready as well, we now need to create a private DNS zone. So we go to cloud DNS over here, we create a zone. This will be a private type. I'm going to name it as OCP private zone. For the DNS name, You can give any name that you want, but in my case I'm giving it hamzacluster.openshift.com. We need to ensure that this is the same one that will be assigned within our install-config.yaml file. Basically, this cluster name should be the same one that you assigned within your install config for the cluster name, and this would be the exact base domain which would be specified inside of your install-config.yaml file. For the options, let's keep it private, and for the network, it needs to be part of the OCP network. Okay, so we have our private DNS created as well. The next step for us is to create the Bastion host. In my case, I've already created my Bastion host, but I'm still going to show you how it needs to be created. You just come to Compute Engine and click. I already have this node ready, but I'll just show you how this needs to be done. Create the instance. You can give it whatever the name that you want. I've given it a Bastion node, for example. The region, it needs to be the same one where you are going to be spinning up your cluster. Any zone is fine. I've selected E2 medium for the instance type. For the boot disk, I have used the Ubuntu operating system. 18.04 is fine. For the size, I think 15 gigs is also fine. Select it. Okay, and for the identity and API access, you can keep all the stuff, all the configurations to the default, but except for this one, for the access scopes, you need to allow full access to all cloud APIs, else you will not be able to run your Google Cloud commands from the from your Bastion host. Let's allow the firewall for HTTP and HTTPS traffic. For the networking component, we need to assign here the network tag. This is very important for that firewall rule that we created earlier to be applicable to this node. You can give a host name of whatever your preference. Keep IP forwarding enabled. For the NIC card, I have selected VirtIO. Actually, that's the one which is supported with this operating system. And for the network, you can select OCP network. It needs to be of a part of the master subnet. And for the primary and external, you can keep it ephemeral. For the network service tier, I don't need premium, sorry. I'm going to keep it to standard and click on done. And finally, for the security, you can turn off your integrity monitoring. And for the manage access, you should basically supply here the public key of your local host from which you are planning to SSH into this node. This is very important. Without this, you will not be able to SSH into your node. And once you've done the configurations, click on create and you're good to go. Once your instance is created, your instance should populate in the list of compute VM instances, and it should be having an internal and a public IP. You can use this public IP to SSH into your node using the public key from your terminal. I have already created this node and I've already SSH'd into this node using my private key and public IP. So now we are good to start off with our installation process of the OpenShift. First things first, we need to update our repositories and download some important packages, which is the wget and the git tool that is very important. The next step for us is to download the necessary binaries. I have this GitHub page, and over here I've already linked the RedHat Cluster Manager link. If you click on this, it should take you to the link where you can log in and you can download your OpenShift related binaries as well as your Red Hat CoreOS operating system. I'll go to OpenShift. Within clusters, I'll click on create a cluster. Scroll down, let's click on Google Cloud, user provision infrastructure. For the OpenShift installer, I have to select Linux because that's what my Bastion host is running. Copy the link address. Let me go back here, wget, and this will basically download the tar file. The next step is for me to copy my pull secret. You can simply click on this button and open up a text editor on your Bastion host, paste it over there and save it. In my case, I have already created my pull secret. As you can see, I already have it present over here. So now we are having our OpenShift installer and the pull secret already present on my node. The next one is the command line utilities. I will have to once again select Linux, copy the link address, and on my Bastion host I'll use the wget tool to download my CLI binaries for the OpenShift. It will download the OC, the kubectl, and the OpenShift install binary. The next step is for us to download the Red Hat core operating system. Copy the link address again as before, and you can once again run the wget, paste the link, and press enter. This will basically start downloading the Red Hat Core OS operating system. I'm not going to download it because I have already downloaded these files from before. As you can see, I'm having this Red Hat Core operating system already present on my node from before. So the next step for us is to extract our binaries and put them into the USR local bin directory so that we can access them. So I'm going to copy these commands from the GitHub link. Let's run those. Once you have your binaries extracted and put into USR local bin, you can check the version of your binaries. As we can see, my OpenShift install is running 4.10.3. So should be my client version as well for the OC. Okay, so we are good to go now. The next step is for us to create an SSH key pair. You can use the SSH keygen command to create a new key pair. In my case, I have already created my key pair from before, but I'm just showing you how this needs to be done. I'm going to Control C from here, but you will have to just create a new key pair and grab the public IP which needs to be put within your install-config.yaml file. So just to show you, my public key pair is present under ss.ssh id sa.b. So this is basically my public key. So the next step for us is to clone this git repository that has been created. I will run the git clone command. Okay, so now I have cloned my repository. As you can see, I have it present over here. This is the repository. And the next step for us is to copy the deployment manager template files into my current working directory. So these are basically the 4 deployment manager template files that are required to spin up our OpenShift cluster. These will be called in a few of the later commands. So the next step is for us to create the install directory within which our manifests and our config files would be created. I have also shared a sample install-config.yaml file in this Git repository. You can use that and copy it into your installation directory. I will just show you what changes need to be done within this file. So this is the installation config YAML that I've shared. The first, you need to basically change your base domain. You can keep it to openshift.com as per your preference, but you can change it as well. Your cluster name needs to be different. This needs to be of any of your choice, and especially for your GCP platform related parameters, this needs to be the actual project ID, which can be grabbed from your GCP console. This is the name of your network that we created, the region where you want to deploy your cluster, and the 2 subnet names that we created. These can be different in your implementation. A few important parameters here is that this is going to be an internal cluster. That's why we are not going to be creating any kind of public DNS entries. And here you need to supply your pool secret that you will be grabbing from your Red Hat cluster manager, and this would be the SSH public key that we just created in one of the previous steps. Once you have created, you will have to copy this file into your install directory. In my case, I have already created a sample install-config.yaml file, and I'm just going to copy up this one to my install directory. Okay, so I have copied my installation file. The next step for us is to basically, what we need to do is we need to move over our service account key that we had created earlier to my Bastion host. So I'll just quickly grab the name of my service account key from my GCP console. And service accounts. Okay, so it's OCP SA2, but from the downloads folder, I suppose it should be a different file name. Let me just quickly go to my downloads folder. Yeah, it's of the file name of 9C18. So let me just quickly go back to my system. I'll just SAP this file. This is my JSON file, and this needs to be transferred to my Bastion host. I'm going to be putting in my public IP, which is 35.2.3.18.161 in the home directory of the user. Okay, so I have it transferred to my home directory of the normal user, so I just need to copy it to my current directory now. So this is my key, and I need to copy it locally, and I'm going to name it by the file name of service account key.json. I'm naming it this one because this is the service account JSON key file name that is called within a few of our upcoming commands. So let's save it with this file name, and now let's export the Google application credentials using this service account JSON key file. This needs to be the path to your JSON key file that we just copied over. So now that we have this in place, we should now be able to create the manifest files as well as the ignition config files, as well as all the upcoming Google Cloud related commands. Okay, so now that we have our manifest files created, we need to make a few changes within the manifest files. The first one is over here in our ingress default configuration. The change that needs to be done is we need to remove this load balancer section, and I'm going to change this type to host network. This is because I just want to specify my own routing because we'll be creating another internal load balancer that would be forwarding traffic to these worker nodes. The replicas would be 2 in our case, because these are the number of worker nodes that we're going to be running. And once you've made the changes, we also need to remove the master and the worker machine set config files. This is because we're going to be creating these nodes using the Google deployment manager template files. So now that we have the changes made, let's create our ignition config files. Okay, now with this in place, now we need to supply a few very important environment variables. These will basically set all the necessary parameters that would be set within our deployment manager template config files later that we'll be creating. You can echo maybe the infra ID to see if it has been set correctly. Yes, it has been set correctly. Let me also just echo my cluster name. That's correct, that's my cluster name. Okay, so now that we have our environment variables set, we now need to create an internal load balancer for the load balancing of API server traffic. If you just inspect this file that we just created, the o2_infra.yaml file, you can see that it has captured all the zone names, the infra ID, the region, and the cluster network and the control subnet. These were basically the parameters that we just supplied through the environment variables. So we have this thing in place, and now let's go ahead with creating of this Google Cloud object. Now this command, what it will do is it will create a load balancer, it will create a cluster IP for the load balancer, and it will also create 3 empty instance groups within which we will be putting our master nodes when we create them later on. Okay, so we have this load balancer component and the respective instance groups created. Now we need to set the cluster IP environment variable. Just echo the cluster IP. to see if it's been correctly set. Yes, it has been correctly set. And now we need to create a few DNS record sets. These are basically the record sets required for all the API related communication within our cluster. Now I'll just quickly show you what this has done. This last command, what it has done is, if you just come to the network services and cloud DNS, let's click on our DNS, private DNS zone. As you can see, it has created these two new record sets with the cluster IP that we had created earlier, the one 10.20. This is the load balancer IP address, and we've created these record sets so that all the API related communication between our cluster nodes can take place. Okay, so the next step for us is to set two new environment variables for the master service account email and the worker service account email. This is just to add the metadata when we are creating our master and the worker nodes. Next step for us is to create two Google Cloud buckets. One would be to hold the ignition config file for our Bootstrap node, and the other one would be to hold the RedHat Core OS operating system. So we have the first bucket created. Let's create the second bucket. I'm basically copying all these commands from my GitHub link directly, so that's why these commands are appearing very quick on the screen. But if you just refer my GitHub page, it should be very, very clear as to how these commands are taking an approach over here. Okay, and lastly, we're going to be creating the actual Google Cloud Compute image object. Okay, so now that we have our Core OS image object created, we now need to just create a new environment variable for the cluster image. This is basically the URL for the Google Cloud image. Let's also create the URL for the Bootstrap ignition config file. Finally, let's create the config YAML file for our Bootstrap node. Yes, it has taken up all the environment variables correctly. And finally, let's deploy the Google Cloud object for the Bootstrap node. Okay, so now that we have our Bootstrap node created, what we have to do next is to actually put this Bootstrap node as part of the instance group that is also created. And we will also make this instance group as one of the backends of the load balancer that we created earlier. This is because our initial temporary Bootstrap cluster would be hosted on the Bootstrap node. That's why we need to put this behind the load balancer that we created earlier. Okay, so now that we have everything in place from a Bootstrap perspective, from a Bootstrap node perspective, we now go ahead with the creation of the master nodes. First things first, we need to set the environment variable. We need to set the environment variable for the master ignition config file. That's this. In this case, we don't create any bucket. We just simply supply the file itself. Let's create the config YAML file for our master node components. And finally, let's create the Google Cloud object for the master node instances. Okay, now that we have our master nodes created, we need to add these three master nodes as part of the three empty instance groups that we had created at the time of load balancer creation step. So for that, we supply these commands, these Google Cloud commands. These will basically add the nodes to the respective instance groups. We can quickly see these from the load balancing section of the Google Cloud platform. So this was the load balancer that we created earlier. In this, we can see that there are four instance groups. One is the Bootstrap node that we just created earlier, and these are the three instance groups within which we have added our three master nodes. Let me just refresh the page. It should probably show 0 of 1 for all of these. As you can see, it's 0 of 1 for this one. I think I may not have. Okay, I think it might just take a couple of minutes to reflect correctly. Let's refresh the page again. There we go. So it's all 0 of 1. So now at this time what's happening is our Bootstrap process is taking place. What we can do is, let me just quickly SSH into my my Bootstrap node. And from my Bastion host, I will SSH into my Bootstrap node basically. Use the core. Where's the username? Let me just grab the IP address of my Bootstrap node. That's my Bootstrap internal IP. Let's paste it. Okay, so inside my node, and let me run this command. This is basically the command to watch all the Bootstrap related logs. So as you can see at this time, it is trying to create and bootstrap the master node components. Alternatively, what you can do is you can also go ahead with the monitoring of the container creation on the master nodes themselves. Let me also SSH once again from a new terminal window to my Bastion host. And I'll supply the IP address of my master node, which is 24 in this case. Okay. I suppose the node is yet to come up, so it is still just refusing my connection to the node, or it might be in a reboot state at this time. Let me try SSHing it once again. Okay, I'm able to SSH into another of my master nodes. So let me just sudo and run a cry_ps. Here I'll be able to see all the containers that are being created at this time. I think this node is yet to get rebooted because it doesn't have the cry_ps yet functioning at this time. I suppose this node will disconnect my SSH session as expected. So this is an expected scenario. You will often see that at least once your master nodes would reboot at the time of Bootstrap. Let me see if I'm able to SSH into one of my other master nodes. Yes, I am able to SSH now. So let me once again sudo to the root user, run a cry_ps. Okay, it is still in the rebooting phase. Let's give it a couple of minutes and it should start spinning up all the containers. There you go. So as we can see that at this time my containers are spinning up. The most important containers that I would say to look out for is the etcd and the kube API server related components. Actually all the necessary kube related components are very important. You might notice that at times your kube API server and the etcd containers might keep on flapping, and that is completely okay. It just takes some time to stabilize. I have seen this difference on 4.10.3 as compared to 4.9, that it takes a longer time to stabilize on 4.10.3. You might also notice that your containers might not come up. So what you might want to do is you might want to perform a rolling reboot of all your master nodes only. Do not reboot your Bootstrap node. Just try to reboot your master nodes in a rolling fashion, and eventually all your master node components would come up. So at this time, I'm just going to be pausing this video, and we will come back once the Bootstrap process is complete. Now that our Bootstrap process has completed, as we can see, these are the logs of our Bootstrap process. It clearly indicates that the Bootstrap service has succeeded. And on my master nodes, I can see that the Kube API server containers are now present. I can see my Kube API server is present on all the three master nodes. Here it is present from before. So these are a few important containers like the Kube API server, the etcd, the controller manager, and all the necessary Kube related components that need to be present. Just to let you know that I also had to reboot my master nodes in a rolling manner fashion, and it took about 20 minutes for this entire Bootstrap to complete. So just have some patience and just wait for this Bootstrap process to complete. So now we are good to remove all of our Bootstrap components. So I'm going to be copying this command that will remove all my Bootstrap related components. First one is to remove the backend from the load balancer. The second one would be to remove those buckets that we had created, which was containing our Bootstrap ignition file. And the last one would be to delete the actual Bootstrap deployment. Okay, so now that our Bootstrap components have been deleted, we are now good to add our worker nodes into the cluster. So let's first of all set the environment variable for our worker ignition config file. The next one would be to create the config.yaml file. We just inspect this file once quickly. Yes, it has picked up all the necessary variables. And finally, let's create the actual Google Cloud deployment object. Okay, so now that we have our worker nodes created, these worker nodes would still not populate as part of our OC get nodes command because we still haven't approved the certificates yet. Before we approve the certificates, let me just show you one quick thing about the cluster operators. At this time, if you see, there are still a few cluster operators which are still not completely available. It's like the console, we have the ingress, we have the authentication. This is because it requires some components on the worker nodes to be present, and only then will these cluster operators reach its completion. So let's go ahead and try to approve the CSRs that would have been created. There should be two pending CSRs first from the worker nodes. Let's give it some time and it should eventually populate over here. Let me just grep for pending. Let's just keep an eye on it. Okay, so we have the two CSRs here now. So let's approve these two first. OC ADM certificate, approve. Let's also approve the second one. Now that we have approved these two certificates, there should be two additional CSRs that would be generated by these two worker nodes. So let's just grep for the pending. There we go. We have a new CSR created by one of our worker nodes. There should be another one also. So basically there will be 4 CSRs in total that you'll have to approve. Okay, so we have approved all our CSRs, and now if we do an OC get nodes command over here, there we go. Our nodes are showing part of the cluster, but it's still not ready. It will show up ready in just maybe a couple of minutes. First one. Meanwhile, this node is coming up as ready. What we have to do next as part of our process is that we have to create a new internal load balancer. But before we create a new internal load balancer, we need to create two instance groups that would be holding our two worker nodes. So let's create two instance groups at this time. These would be two unmanaged instance groups. Let me call them as worker 0 instance group IG. Needs to be part of the same region. It's the worker subnet, and the VM would be 1. Since it's 1, let me just change the name to worker 1 instead. And create. So we've created one instance group. Let's create the other one now. Again, the same settings as before. My other zone where my worker 0 VM instance would be present. There we go. And let's create it. Okay, now that our instance group is created, let me just go back and see if the node is ready now. Yeah, it is ready. All my cluster nodes are ready at this time. So now that we have our instance groups created, we can now create the load balancer. Let's go to network services and load balancers. We already have one which was created from before. Let's create another one. It will be of type TCP. Only between VMs, single region is fine. Let's give it a name. I'll call it as worker plane LB. Again, the same region and the network of OCP network. For the backends, we need to select both of our instance groups, worker 0 as well as the worker 1 instance group. And for the health check, let me create a new health check. I'll give it a name of wildcard. Okay, it's already populated because I had created one earlier. The scope can be regional, protocol is GCP, the port would be 443. And let's keep the remaining stuff as default. Create. Now that the backend is created, let's create our front end. We don't need a name. The protocol is TCP, and the subnet for the front end would be the master because we need it to listen from the master subnet. It can be shared. The IP address can be ephemeral. Ports, let me give it all the ports. Global access, no, we don't want that. And create. Okay. So now that we have this load balancer created, we need to get the IP address of this load balancer. So while while this load balancer is getting created, let me just show you one quick thing on the Bastion hood. Now, if we do an OC get CO at this time, we can see that these operators, these cluster operators, are eventually starting to come up healthy. Especially the ingress one is healthy right now, but I'm expecting this to go down soon because at this time there is no route or there is no valid way for the communication between our master nodes and for the worker nodes when it comes to the application related traffic, because we don't have the DNS entry yet for the wildcard for the wildcard entry of apps. That is very important. So that is what we are going to create next. For this purpose, let's go back. Let's go to the load balancer. Let's grab this IP address. This is the IP address that will be used within our private DNS zone for the record set entry. So let's create a new record set. Let's call it as star apps because this is a wildcard entry for this host header. TTL would be 1. Routing policy can be the default one. Record type is A, and the IP address is the one that we just copied, which was the load balancer IP address of the one that we just created earlier. And let's create. Once we have this thing, okay, there seems to be an issue here. Okay, yeah, there is a slight typo over here. There we go. Let me just create it again. Okay, so now that we have this thing in place, let me just go back to our terminal and let me run this command watch oc get co. Now that we have our DNS entry correctly set up, we should eventually start seeing all our cluster operators reaching the completion stage. Because now there is a proper way of communication between the cluster nodes, and it can establish a legit route for all the main cluster operators like the console, the authentication. Okay, so our ingress operator became healthy. It's available. Our console operator also got healthy. It's available now. Okay, so now that we saw that our cluster operators are becoming healthy and available, we need to find out how exactly do we have to reach our OCP console UI, and we can get that by this command, which is the oc get routes command in all the namespaces. So these are basically the endpoint host URLs on which we can reach out these individual components, like we have the Grafana dashboard, the Prometheus dashboard, the actual console of our OCP cluster. What we have to do next is we have to add a route for all of these host URLs within our etc hosts file locally on our local machine, and also we will have to we will also have to configure a reverse proxy on our Bastion host, so that whenever we try to reach out the public IP, or basically this URL, and it will be directed to this public IP, which is our Bastion host, it will forward the traffic to the load balancer IP address of our worker nodes. So let's do that now. First things first, I will be installing the HA proxy reverse proxy. I already have it installed, but I'm still going to be running the command. Here it is. We need to make some changes to the configuration file. I had made the changes from before. So basically, this is the change that you have to do in this last line for the backend servers. This line. This name needs to be the name of your DNS name, and this needs to be the IP address of your load balancer cluster IP, of your worker plane load balancer that we just created earlier. So in my case, it is already created. Let me just do a systemctl restart HA proxy. Now that we have our reverse proxy configured, we also need to add the local route on our local host. So from a new tab, I'm already a root user. Let me open up the etc hosts file. And here, this is the entry that is very, very important. This is the entry that will tell our local host to forward the traffic to the public IP. This is the public IP of the Bastion host whenever any host URL of these names is input into the browser. So we are also using the console OpenShift of our OCP cluster. This is the URL that we just grabbed from the OC routes command over here. These are basically all the host URLs that I have put in as part of this single line over here. So once we have this entry put into the etc hosts file, I will save it, and we can now try to access this URL. You just grab this one, copy it, let me just open up a new browser session over here, and let me paste it over here. There we go. So we are now able to access our console of the OCP cluster. It will show double verification probably. You'll have to proceed it twice. You'll have to acknowledge this message twice. And for the username, your initial username would be kubeadmin, and the password can be grabbed from your Bastion host. It should be part of your install directory under the auth directory that it creates under the file name of kubeadmin password. So this is my root password. Let me copy this. No, sorry, it's my kubeadmin password. And let me get back to my UI. Let's paste it and enter. So I'm now able to access my OCP cluster UI from my local host of my OCP cluster, which is hosted on the GCP platform. Likewise, I can also access my Grafana dashboard in a similar way. All I have to do is just grab this URL. Let me go back to my browser, open up a new tab, and let's paste this one. There we go. So we have this thing in place right now. Log in with OpenShift, allow the selected permissions, and we are now able to access our Grafana dashboard for the OpenShift cluster. One last thing is that you can also check your availability of your cluster operators. Let me just do an OC get CUI at this time. There we go. We can see all our cluster operators are available. This means that we have successfully installed our OCP 4.10.3 platform on Google Cloud. I hope you've liked this video. I hope this video was informative, and I really hope you're able to deploy your OCP cluster on Google Cloud. Let me know in the comments what you feel about this video. Any feedbacks is most welcome. I hope they are constructive feedbacks. Thanks a lot for your time for watching this video. Thank you.